Okay, this lesson is on maximum and minimum problems involving quadratics. The key thing to remember in solving these problems is that the maximum or minimum of a quadratic function occurs at the vertex. When we graph a quadratic function, we get a parabola. If the parabola opens downward, then the vertex up here represents the maximum value of the function. If our parabola opens upward, then the vertex is down here and it represents the minimum value of the function. As an example, as our first example, let's look at this problem. A farmer has 120 feet of fencing to enclose 3 sides of a rectangular area bordering a building. Find the maximum area he can enclose. So we have a situation like this. We've got a building, and next to the building we are making a rectangular enclosure, and we only need to enclose 3 sides. The building is the 4th side. And so I have 120 feet of fencing to cover these 3 sides. Now I could make this a long rectangle. I can make it more square shaped, just as long as I use the 120 feet of fencing. But we want to maximize the possible area. Here we want to maximize this area. Now let's let x be the width of the rectangle. So that would go there and there. Since I have 120 feet of fencing to work with, if I use x feet on one side and x feet on the other, the amount of fencing which I have left for the length here would be 120 minus 2 x's. So that's the length. So the length is then 120 minus 2x. Now I want the maximum area for this rectangle. The formula for the area of a rectangle is length times width. And if I plug in what I know, the area A is the length 120 minus 2x times the width x. Now if I distribute that x, you'll notice that this is a quadratic function. It's negative 2x squared plus 120x. And since it's just a function of x, I can even use function notation here and write that as a of x. That's my quadratic function. If I plug in a value for x, a width value, then it's going to tell me what the area of the rectangle would be. But remember, I want the maximum area. Now if you notice, from this value a, since it's negative, that tells me that this is a parabola. If I graph it, I get a parabola which opens downward. And if I make a very simple sketch here, x-axis, and this is the a-axis, or a of x, graphing this parabola, I would get something like this. It has a maximum value. The maximum right there is at the vertex. So all I have to do to find the maximum area of the rectangle is to find the vertex of the parabola. To do that, I'm going to use the line of symmetry. The line of symmetry is x equals negative b over 2a. And if I plug in b here, which is 120, so we get negative 120, over 2 times a is negative 2, and I simplify that, I get x equals 30. And that's the first part of the vertex, actually. This point right here is 20 comma something. To get the second part of the vertex, I plug in x equals 30 into the function. A of 30 is equal to negative 2 times 30 squared plus 120 times 30. And if we simplify that, we get an area of 1,800. And so this right here is 1,800. That's the vertex. And I have found the solution to my problem. The maximum area is when we make the width 30. So the width is 30. That makes this over here also a 30. The length would then be 60 if you plug the 30 in for the x there. And you multiply those together, 30 times 60 does give us the maximum area is, let's fix that, area is 1,800 square feet, which is the y value of the vertex. And we've solved our maximum minimum problem. Let's do another one. Find the pair of numbers whose sum is 10 and whose product is a maximum. Okay, so let's let x be the first number. Let x be the first number. Since their sum is 10, the next number, or the other number, is then 10 minus x. That's the only way that they could add up to 10. If one's x, the other one has to be 10 minus x. Now we want to maximize their product. In other words, when we multiply them together, we want the maximum possible value. So I'll use P for product. We want to maximize the product when I multiply the two numbers together. So that would be x times 10 minus x. This is a function of x, P of x. If I distribute the x and reverse the terms, it's negative 1x squared plus 10x, which is a quadratic function. Notice that this function, this quadratic function, if I graph it, gives me a parabola which opens downward. It would look something like this. And so right here, we have a maximum which occurs at the vertex. And so to find the maximum product, I just find the vertex of the parabola. So just like in the last problem, I'm going to find the vertex by using the line of symmetry, negative b over 2a, which in this case would be negative 10 over 2 times negative 1, which is 5. X equals 5 is the line of symmetry. Plug that into the function. P of 5 equals negative 1 times 5 squared plus 10 times 5. And if we work that out, we get 25. So the vertex is located at 5, 25, which is right up here. Okay, and so we have the answer to our problem already. It says find the pair of numbers. Well, the first number is x equals 5. Now, if the first number is 5, then they have to sum up to 10. The second number is also 5. So 5 and 5 give a maximum product, and that maximum product would be this number right here, the maximum height of the parabola, 25. And so in other words, if you want to multiply two numbers together and get a maximum value, you should make them the same number, like 5 and 5. Okay. Let's look at another maximum and minimum problem. A rocket is launched from ground level. Its distance in feet from the ground in t seconds is given by that function. At what time will the rocket be 550 feet from the ground? Notice that this is a quadratic function. We have a negative 16t squared, and so that's a parabola which opens downward again. And so making a very simple sketch, what we have is this situation, which makes sense because if you launch a rocket, it's going to go up, and then it's also going to come down after a certain amount of time. This is the t-axis, and this is the distance or the height of the rocket. We want to know at what times will the rocket be 550 feet from the ground. And so what I'm going to do, that's a d, that's a distance, d of t, is 550. So I'm going to plug that in to the, let's put it down here. I'm going to plug that in to the function here for d of t. 550 equals negative 16t squared plus 208t. And if I solve this equation for t, then I'm going to get the time at which the rocket was 550 feet. So let's solve that for t. We need to, I'm going to move everything to the left side. 16t squared minus 208t plus 550 equals 0. Now, I doubt that that quadratic factors, so I'm going to solve that quadratic by using the quadratic formula. So I'm going to write that right up here. The quadratic formula, t will equal negative b plus or minus the square root of b squared minus 4 times a times c over 2a. Plug in our numbers. Now, b is negative 208. Negative 208 here, negative 208 there. A is 16, and b is 550. This is going to work out to be 208 plus or minus the square root of, let's see what we have in our square root sign, 208 squared, and then minus 4 times 16 times 550. 8,064. Oops. Try that again. All divided by 32. Okay. Now I'm going to get two answers. If I use the plus sign, 208 plus the square root of 8,064 divided by 32. And if I use the minus sign, like that. Getting a decimal approximation by using my calculator. Let's see what the first one gives us. This one is approximately 9.3. And the other value is approximately 3.7. And we have actually two answers to this. The time that the rocket would be 550 feet from the ground is 3.7 seconds and 9.3 seconds, which makes sense because if this were, let's say, 550 feet here, then on the way up, the rocket would hit this distance, this height from the ground, and this one must be the 3.7 seconds. And then also on its way back down here, it's now at 550 feet again, and that must have occurred at 9.3 seconds. And so we found the two values that we were looking for. All right, another one that is similar to this. A projectile shot straight upward with initial velocity 40 meters per second is shot up with a initial velocity of 40 meters per second. The height in feet is given by this function here. T is the number of seconds after it's been fired. At what time will it reach its maximum height? What is the maximum height? So this is a minimum problem again. Notice that this represents a parabola. This quadratic here is a parabola which opens downward again, and so it would look something like this. It has a maximum height which occurs at the vertex. And so if I want to know the maximum height of the rocket or the projectile, all I have to do is find the vertex. The maximum occurs at the vertex. I'll use my line of symmetry method, negative b over 2a. Up here, b is 400. A is negative 16. And I'm going to get a decimal approximation to that. 400 divided by 32. Oh, well, it's 12.5. 12.5 is our x value. Actually, it's a t, isn't it, here? Let me fix that. I don't have x's here. I have t's instead. So it's t equals 12.5 seconds. In other words, the rocket reaches its maximum height after 12.5 seconds. So the maximum height occurs at 12.5 seconds. We've answered the first part of this. In other words, if this is the t-axis and this is the height, the first part of the vertex is 12.5. That's where it occurs. Now, what is the maximum height? Well, all I have to do is plug in the 12.5 into the function. H of 12.5 is negative 16 times 12.5 squared plus 400 times 12.5. And working that out using my calculator, I end up with 2,500. And so the maximum height is 2,500 feet. Let's write that down. The maximum height achieved by the projectile is 2,500 feet. And that would be the second part of the vertex here. 2,500 feet right there. And that's how we use quadratics to solve maximum and minimum problems.